Okay, this is chapter, what are we on, 5.4? So this is video number 2. So we've looked at the sum and difference formulas, and we can use the sum and difference formulas to verify identities, and specifically cofunction identities. So we were introduced to cofunction identities back in the earlier parts of chapter 5, and the cofunction identities basically say something like this, like the fact that the cosine of pi over 2, or 90 degrees, minus some other angle equals the sine of whatever that angle is. So we can use what we've learned in terms of the sum and difference formulas to verify it, to prove. We're, again, verifying is showing that this equals this, one side equals the other. So we're going to do that, and we will use the fact that cosine of A minus B equals cosine of A times the cosine of B plus sine of A sine of B. So we will write cosine pi over 2 times the cosine of x plus sine of pi over 2 times the sine of x. All of that's going to equal sine of x. So what is the cosine of pi over 2? Cosine of pi over 2, which is here, this is 0, 1. So the cosine of pi over 2 is 0. So this is going to be 0 times cosine x plus the sine of pi over 2 is 1. I should have done this. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so this is going to be 1 times the sine of x equals sine of x. All right? So 0 times cosine, 0 times anything, it's done. 1 times sine, so this equals sine x equals sine x. Check. So using the sum and difference formula, we're able to show, to verify the cofunction identity, that indeed cosine of pi over 2 minus x equals sine of x. All right, so let's verify. Let's verify here. We're going to go, this is going to be sine of theta times the cosine of pi over 2 minus the cosine of theta times the sine of pi over 2. All of that should equal negative cosine theta. So we have sine theta, and the cosine of pi over 2 is 0, minus cosine theta, and the sine of pi over 2 is 1, equals negative cosine theta. All right? That cancels out, and negative cosine theta times 1 is negative cosine theta equals negative cosine theta. Check. Verified. Okay. Now we're going to come down here. I'm going to make a little line. Do this in blue. We're going to go cosine of x times cosine of y minus sine of x sine of y. That's this piece here, right here. Okay. Plus cosine of x cosine of y plus sine x sine y, and all of that should equal 2 cosine x cosine y. Okay, this is this part. This is what we're trying to prove. All right, now we come in here and we look, and we notice that we have negative sine x times sine y, and here we have positive sine x times sine y, so they cancel each other out. That leaves us with cosine x, cosine y, plus cosine x, cosine y equals 2 cosine x, cosine y. Add those two together, and we get 2 cosine x, cosine y equals 2 cosine x, cosine y. Check, we verified it. Okay, moving forward. All right, evaluating expressions. So here we've got inverse trig functions, arc, cosine, arctangent. So we need to remind ourselves something. Let's do a little reminder over here. Do reminders in green. We'll say, so cosine, the inverse trig function is an angle equals theta. So we're saying basically cosine of some angle is root 2 over 2. Well, what angle has, the cosine of what angle is root 2 over 2? Well, theta equals pi over 4. Okay? And then same thing over here we go, okay? Arcsine of 0 equals some angle. So the sine of theta equals 0. Let me clean this up a little bit. I'm being sloppy. So sine of theta equals 0. So what angle has a sine of 0? Right here, this is 1, 0, so the sine is 0. We're dealing just in, again, we have to remember the world we're living in. So why is this root 2 over 2? Why is that pi over 4? Going back to this one, why is it pi over 4? Well, it's because our cosine has to be right here, okay? So that's pi over 4. And then for sine, for here, this is 0 because it has to be here. So even though the sine of pi is also 0, okay, that's not within the range of arcsine. It has to be within this area here. So that's why we know it's 0. Okay, now that we've got these, okay, let's just go. It's on the unit circle, so we don't have to expand. We're not going to use the formula to expand this out because we're on the unit circle. So we don't have to use the formula. We just have to now say, okay, we want the tangent of this angle, because this is basically saying tangent A minus B. A and B are angles. This is A, this is B. So this is pi over 4 minus 0. Okay, so that's the tangent of pi over 4. And the tangent of pi over 4 equals 1. Pi over 4, root 2 over 2, root 2 over 2. The tangent of pi over 4 is 1. Okay, hopefully that makes sense. Okay, let's do the same thing over here. Let's come over and go, we have this angle, so this is, do this in red. This is A, this is B. So we already have A, it's pi. We have to find B. So arc cosine of -1 equals 0, equals theta. Why do I keep saying 0? So cosine of the angle equals -1. So what angle has a cosine of -1? Well, theta equals pi. So this, we write this equation as cosine of pi minus pi. Okay, pi minus pi is 0. The cosine of 0 angle, here's a 0 angle, this is a 0.10. The cosine is this, so the cosine of 0 is 1. Okay, these are simple. It's a lot of like, oh, this, that. I mean, it seems kind of complicated. It seems like we're just sort of, but that's what it is. This is trig. So you got to just kind of embrace it. Okay, I think we're going to do this, and then we're going to stop. I'm going to go home, walk my dog, and do the rest of these. Triangles, okay? Before, up here, we were dealing with angles that were on the unit circle, right? This is all unit circle stuff, unit circle stuff. Now we don't have unit circles, so we have to draw triangles. And we have to think about where we are, and we have to think about the properties. So we'll call this U and V, right? So U, the angle U, okay, the angle U equals arc sine of negative 12 over 13. So the sine of U equals negative 12 over 13, all right? It's negative 12, opposite is negative 12. Sine has to either be in the first quadrant, in Q1, or in Q4. So since 12 is negative, we know this is a negative 12. This is 13, therefore special right triangle, that's 5. If you don't know your special right triangles, then you're going to have to do the math. You're going to have to do a squared plus negative 12 squared equals 13 squared, and do that. But if you memorize the right triangles, then you have no math that you have to do. Okay? And so let's just go ahead and write it in here. So that means that cosine of U equals 5 over 13. Okay, we're going to do the same thing with V here. V equals arc cosine of negative 8, 17. Now, cosine has to either be in Q1 or Q2. Since it's a negative 8, this is negative 8, we know it's coming out here. Okay, negative 8 and 17. Okay, here you are going to have to come in and do negative 8 squared plus b squared equals 17 squared, and b equals 15. Positive 15, because we're in the second quadrant. Okay, that's what's important here. Okay, knowing which quadrant we're in, and that has to do with the range is for arc cosine, arc sine, where it has to sort of live in. Okay, so in this case, we want the sine of V is going to be 15 over 17. That's a 5. Okay, now we can rewrite this equation with the information we're given. So we can go cosine of this angle here, I'm sorry, let's see, cosine of U, blanking out here, cosine of U plus V, because we now know what U and V are. So cosine of U and V equals cosine of U, cosine of V minus sine U, sine V. So now we use these values that we found. Okay, we're going to use the sine of U, cosine of U, sine of V, and we know the oh yeah, I didn't write it in there, but we know that I wrote it in. Cosine of V equals negative 8, 17. Okay, so let's use that information. Cosine of U, 5/13. Cosine of V, negative 8/17, minus sine of U, which is negative 12/13, and sine of V, which is 15/17. Right, so we have negative 40, what's 13 times 17? 221, yikes, minus negative 180 over 221. This is negative 40, 221 plus negative 180, 221 equals 140 over 221. Whew, a lot. Okay, a lot of basic math coming in, a lot of fractions, multiplying fractions, finding the fractions. Got to get all that sorted out.